Good morning, everyone, and welcome to the webinar today. This is the first webinar in our fall webinar series on communication and fire. My name is Carrie Berger, and I'm the Assistant Program Coordinator for the Northwest Fire Science Consortium, and I'll be the moderator for today's session. To avoid any noise interference, I have muted your audio, so if you have a question, please type it into the chat box. Also, I will be recording the webinar and will archive it on our website and YouTube channel. You can find those web addresses listed in the chat box. I've also added a link to the paper that our guest will be referencing today in his presentation, and that can also be found in the chat box. So we are very excited to have with us today Josh Hyde, who is the Smoke Program Coordinator at the University of Idaho. So Josh, whenever you're ready, go ahead.
Oh, thanks a lot, Carrie. I appreciate the invite to speak about the Smoke Management Photographic Guide, and glad that there's interest in it. So we'll be talking about the guide today that was developed by myself and my co-authors, Dr. Jared Blades at the University of Wisconsin, Dr. Troy Hall at Oregon State, Dr. Alistair Smith at University of Idaho, and Dr. Roger Ottmar, the Pacific Wildland Fire Sciences Lab. So I'll go into kind of the approach that we took to put the guide together and our methodology, and wrap up with a little bit about its use, and then we should have plenty of time for questions. So the photo guide was spurred out of a joint fire science program project on public perceptions of smoke by Drs. Hall, Smith, Ottmar, and Blades, focusing primarily on contrasting the smoke tolerance among wildland-urban interface and urban communities in the interior west and south-central United States. But part 3 of the project was focused on improving communications of smoke. That was done through a couple different ways. The researchers developed a series of YouTube videos on the topic that are openly available. And secondly, they worked with me to develop this guide, focusing on visual representation of potential smoke impacts and smoke concentrations. So in approaching the guide, we really saw kind of four goals that needed to be met to produce something that would be valuable in a variety of areas. We wanted to have a consistent approach to representing smoke-impaired visibility. We wanted to provide examples across multiple regions of the U.S. Specifically, we wanted to focus on smoke from wildland fires. Visibility can be impaired by a variety of factors, but we were really concerned with wildland fire smoke. And then organize the information in a useful and meaningful way. So to start in on this guide, I began asking around, talking to different folks at the U.S. Forest Service and National Park Service to see what images were available with them that may be linked to smoke monitoring data. And people were super helpful. I got several images and data associated with them. And as I began to collate what I had, a couple things became apparent. First was that there's only so many people you can ask for resources, and I had a few examples, but nowhere near kind of what the ideal would be to represent multiple parts of the U.S. And then what we did have were kind of at the mercy of the conditions while people were sampling. They might have a couple baseline examples and some high impacts, but a lot of that just depended on what was going on while they were sampling. A lot of these were on wildland fire incidences and kind of a mix of what you could get and landscapes that you could get. So it was really challenging to consistently approach these examples, and so that kind of led us to reevaluating our methodology a bit. And we ended up using wind haze software to simulate smoke-impacted landscapes. I don't know how many folks are familiar with the wind haze program, but the images generated by that program are out there in a variety of documents. If you've seen images of landscapes with a clear airshed on one side and a smoky or hazy sample of that airshed on the other, chances are that was generated by the wind haze program. And it uses images and monitoring data from several longer-term monitoring sites set up as part of the Interagency Monitoring of Protected Visual Environments, or IMPROVE. So this got at a couple of those goals, being able to simulate samples from multiple areas, because they had a fair number of sites available in wind haze, and also approaching this in a consistent manner. And in a couple minutes we'll go through the way that visibility impairment is simulated in wind haze, and kind of how we started in on that from the perspective of smoke specifically. So within wind haze, there's images of view sheds from the sampling sites, and these could be matched with the monitoring site information. So from there, we could find good places on the landscape to represent, get the approximate distance to those. Then we were able to verify that with some of the wind haze developers. So that allowed us to get at mileages on the landscape to call out certain landmarks, and in most cases in the guide, these are rounded to the nearest half mile. And the next step was looking at wildland fire smoke specifically to simulate smoke impacts on these landscapes. The way wind haze achieves this is through the equation by Malm et al. In 1994. And that's based on a relationship between relative humidity, light scattering, 5 species of particulate matter 2.5, those particulates that are 2.5 microns or less in diameter, specifically ammonium sulfate and nitrate, organic mass, elemental carbon, and fine soil, as well as coarse mass, the particulate matter 10 microns or less in diameter. So we really honed in on this when we started to simulate these images, and here you can see an example of the software interface with the different particulate species on the right and the site data for the particular sampling site on the left. You can see we have the range of dates, the number of sampling days, and then the option to load the best 20% air quality days, average days or worst 20% from that set. And then you can go back through and either use that information to simulate the image, or you can swap out those values with your own, which we used a combination of those two approaches to simulate wildland fire smoke. And you can see the table here from one of the sites in the Smoke Photographic Guide. Has those same particulate species and the various levels. And we really focused on particulate matter 2.5, those smallest particles that are of the most health concern, that are inhaled the most deeply into the lungs and hardest for the body to expel. So as we were looking at the inputs that we would need to simulate the visibility reduction, ammonium sulfate nitrate and fine soil, which in this case would be things like wind-blown dust and that sort of thing, those weren't really likely to change that much as a result of fire smoke. So we really honed in on the organic carbon and black carbon. So as we populated this, we did use the monitoring site data available in WinHaze for that ammonium and fine soil. But for the organic carbon and black carbon, we increased these, and these are really what changed as the images progressed. We increased these until we reached our target PM 2.5 concentration. And organic carbon and black carbon were increased at a ratio of about a little bit over 15 to 1. So 15 parts organic carbon to 1 part black carbon. And that was from work by Andre and Merlet in 2001 that reviewed a variety of emissions from numerous sources, including wildland fire. And that was the average ratio that was found for non-tropical forest fires. So we felt that value covered a lot of what we would be likely to see during a fire season. And even though we focused on particulate matter 2.5, particulate matter 10 still affects visibility and it's still part of that equation. So we had to capture that as well. And we tried to be conservative in our estimates, so we went with the higher of two values. We either used the coarse mass value for the 20% worst monitoring days that were available in WinHaze, or we used 10% of our particulate matter 2.5 concentration. And that was based on work by Ward and Hardy in 1991. And one thing to note in here, kind of a correction factor for the images, that these values would be something that we would use and display next to the images. But there was work done after that 1994 equation by Malm and others, looking at the ability of carbon to absorb relative humidity as it's in the atmosphere, and the way that it increases in mass as a result of that. And they found that at about 80% relative humidity, it could gain 1.2 times of its mass. And so to kind of adjust our images to capture that newer information, we went through and we increased that organic carbon number at that same rate, where at 80% relative humidity it would be be 1.2 times the value of what we had as we simulated the images. And making this correction and going back and looking at the before and after images, I had a really difficult time being able to tell a difference between the two images, especially with the relative humidities in most sites. But we still felt it was important to capture that updated information and try to have our images reflect that. And here, just going back to the particulate matter tables in the guide, we can see the approach I just mentioned, where we have our average values of ammonium sulfate and nitrate in fine soil, and then our 20% worst values that are consistent throughout. And then the organic carbon, black carbon, and coarse mass that are pretty steadily increasing as we represent those increased smoke concentrations. For particulate matter, we felt that represented things pretty well. Then we had to look at relative humidity. For that, we relied on EPA's Clean Air Status and Trends Network data. We took 10 years of relative humidity data from the summer season, so May through September. That was collected at the national park sites in the photo guide. And we took the average of morning and afternoon values for each month. So we were really trying to get at a range of relative humidity for those daylight hours during the wildland fire season. So what the relative humidity would be as the guide was being used. And with those factors, we feel that our goal of addressing specifically wildland fire smoke was sufficiently met. And we used as many sites as we could that had data associated with them, such that we got at least one site per Forest Service region in the continental U.S., and in most cases more than that. Had pretty good coverage over the western half of the U.S. So really the next step was organizing the information in a meaningful way that it would be useful. And the first step in that was choosing the smoke concentrations to represent. Once we were confident that we could represent these landscapes and address smoke from fire, what levels do we use? For that, we referred to Wildfire Smoke, a guide for public health officials. In this case, we used the version from Lipset et al. In 2012. And it contains, as part of that guide, air quality values for different time periods, looking at a 1 to 3 hour average, an 8-hour average, and a 24-hour average, and showing those along with recommended health actions. And in this case, we decided to go with the 1 to 3 hour average, that short-term average. We felt that approach was most appropriate given that we were working with photos, so they essentially are a snapshot in time where people are looking at a landscape and conditions can change relatively rapidly. So we felt that shorter averaging period was most consistent with using photos. And we chose those categories of good, unhealthy for sensitive groups, and unhealthy for couple different reasons. The first was that those are linked to pretty good recommended actions as far as different breakpoints, where if air quality is good, there's not as much messaging that needs to be done. Whereas if it's unhealthy for sensitive groups, you have specific groups of the population that you'd be targeting, as opposed to if it's unhealthy for everyone, you have messaging that you'd be delivering for, say, an entire community. So those categories made sense to represent from that perspective. They also broke out fairly well in the images. So when we chose these values, we took the mid value from each of these categories. So between 0 and 38, we used 19 micrograms per meters cubed. 89 to 138, we used 114, and so on. And in a lot of cases, those showed up pretty well in the images, even without having the values at the bottom of the image. You could still tell in most cases just by looking that there was a noticeable increase in visibility reduction. So as we presented the information in the guide, we did so both in table form, where we had those different air quality values and different visual ranges, going from low humidity and baseline images all the way up to higher humidity and those unhealthy levels. And then we had the visual aspect of the guide, which is the landscape with landmarks pointed out. And in the bottom left are baseline, good, unhealthy for sensitive groups, and unhealthy values. And in most cases, we had all of these. You'll notice in some of the images we stopped at unhealthy for sensitive groups, and that was just because at a certain point there was no more features on the landscape that would be useful. We did still retain the values in the table, though, for each category and each range of relative humidities. So that met our 4 goals. I'll talk a little bit about usage and limitations, and then we can have time for questions. As far as usage of the guide, it's really intended as a communication guide rather than a predictive tool. So an approximation of what certain smoke levels could look like. And for the potential visual ranges from short-term smoke concentrations, that 1 to 3 hour smoke value. And we organize that in both the table form and the series of images. And I'll note that it is one tool that's out there. Some states have their own visibility guidelines and their own ranges that they use. For example, the state of Oregon has a series of mileages that they use in conjunction with 24-hour average air quality values. The state of New Mexico has different visual ranges and health guidelines for different populations associated with those. So depending on where you're working, there might be state visual range indicators that folks are used to using and used to seeing. And one thing to note in both of these, at the bottom, they do have the caveat that no matter what the visual range is, that for people deciding how they're going to respond to smoky conditions, it's really a matter of how they feel physically, what those health indicators are. And that's always an important caveat to keep in mind, that really any physical health effects should be considered above visibility indicators. Limitations for the guide. The images are simulated, and I think that's the main limitation for our approach. Was anytime you're using a simulation, there's always a certain degree of uncertainty. The other limitations, I think, are just more inherent to the process of trying to get at smoke concentrations through visual range. And in communicating with the public, some people may not know the distances to landmarks in their community. And if they do, that process can be a little subjective, where under different sunlight conditions or the color of different objects, whether they're looking at a lighter, say, a rocky mountainside as opposed to like a dark green vegetated mountainside, that can have an impact. Not everyone has the same ability to see the same distance across the landscape, so there's that. And conditions can change relatively rapidly. And those, I think, are just inherent to the process of using visual range in general. But even with those, we work to put together a visual aid that hopefully will be useful in communicating potential smoke impacts to the public. I'd just like to acknowledge and thank the Joint Fire Science Program for the funding for this work under their project, and also several reviewers that reviewed the guide as it was going through the process of becoming a GTR. Members of the NWCG Smoke Committee and others. Mark Fitch, Bill Malm, Susan O'Neill, Janice Peterson, Bob Bananek, and Clint Wright were all very helpful in their review comments. And with that, we should have plenty of time for questions.
That's great, Josh. Thank you so much. That was a really interesting webinar you just gave. And at this point, we'd like to open it up for any questions you might have for Josh. It looks like we have a comment that came in. Nice presentation, Josh. You did such a great job on this guide. It is one of the best deliverables to come out of this work. Take care. So that's really great.
Oh, thank you very much. That's a very flattering comment.
Josh, I'm curious if you've gotten any feedback from folks that have used the guide and what that feedback looks like.
Yeah, so that'll be really, really interesting to see. So this guide, it was at the publishers for a while. It was beginning to come together in spring, and it landed on my desk in late summer as a printed guide. And so it didn't quite get out this fire season. This upcoming fire season will be the first one that it'll be out. And so I'll be really interested to see how that goes. It'll be the first run to see how people are using it and what comments come out. And yeah, so that's something that I'm interested in seeing as well.
I'm looking forward to, right?
For sure.
Well, while we're waiting for questions to come in, I just want to say that the Northwest Fire Science Consortium, we try to offer a diversity of opportunities for people to participate in, and hosting webinars like this is just one way we accomplish that. And if you're ever interested in sharing an idea for a webinar, please don't hesitate to get a hold of us. I'm going to go ahead and put the waiting slide back up with Janine's contact information. I also want to point out that we do have an upcoming webinar on November 18th at 11 a.m., and that's Communication Under Fire, Understanding Capacity for Effective Communication During Large-Scale Wildfires, and you can register at that link there. It does look like we have something that just came in. So can we use wind haze to apply this to our own landscapes? I suspect we could use this to predict impacts to visual quality in the NEPA process.
So wind haze has the images already loaded into the program where they've gone through and analyzed the images and kind of masked out the various distances on the landscape. And so unfortunately, I'm not aware of any way to load your own landscape into that. However, they do have a lot of examples beyond what I used in this guide. They just don't all have air quality monitoring data associated with them. And so there are options to go through if you have something and you want to find a similar landscape. Chances are you could probably find something close. You would just be supplying your own values for it.
Thank you. I've had another comment come in. Since I am now a retired government employee, how may I get a copy of this guide? Also, nice work, Josh. I'll answer that, and Josh can also answer that. On our website, I provided at the beginning of this webinar, www.northwestfirescience.org. You go to our publications and just go ahead and type in that Smoke Management Photographic Guide, and you'll find it on our website. And I'm sure also you can contact Josh.
That's correct. Yeah, we have a few printed copies of the guide as well on our Moscow, Idaho campus. So if someone contacts me, I can pass that along, and we can get those sent to people as well.
Great. We'll just wait another minute for any other questions that folks might have. And while we're waiting, I guess I want to thank you to Josh again for talking with us today. Like I said, that was really interesting, and I'm excited for you to see, what happens this coming fire season with that guide. And I also want to thank you all for taking the time out of your busy schedules to listen in today. And I do hope you consider joining us on November 18th for the second webinar in our webinar series with communication and fire. I don't see any other questions coming in. So Josh, unless you have anything left to say, any last comments or remarks, we can just hope that everybody has a wonderful day, and we'll see them again next time.
Yeah, I won't draw things out too much longer. Just wanted to say thanks to the group for attending, and glad there's interest out there. And thank you, Carrie, for the invite to speak about the guide. And you'll have my contact information. Feel free to follow up with me if more questions come up in the future.
Great. Thanks again, Josh.
Thank you all.